All right, I've stepped back to the beginning of this example because I don't want you to be confused in any way. But this example takes a look at the relationship between good looks and how successful you are. So going back here, the rows are how good looking you are, and yes and no. Okay, so the columns are how successful you turned out to be. Yes and no. Okay, so it's a 2 by 2 table, and let's take a look at how we work this problem. Okay, so real quickly, step one is we state the null and alternative hypothesis. What is that? The null hypothesis is there is no relationship between good looks and success. The alternative hypothesis is that there is a relationship between how good you look and how successful you are. Okay, so let's take step two. This is my recipe, just like when we learned to do the sum of squares in the table of variabilities back in the couple of chapters ago. Okay, so step two is compute the sum for each row and column. All right, so we did that. The rows are 40 and 40, and the columns are 35 and 40. All right, and so 40 and 40 is 80, and 35 and 45 is also 80. Okay, step three is we compute the expected frequencies. So we take the row total times the column total divided by the total number of observations. Okay, so let's take a look. Here's the expected, which is 40 times 35 divided by 80. The expected here is 17.5, 22.5 for this cell, 17.5 for this cell, and 22.5 for this. Okay, so let's pop over, and step three is compute the expected frequencies again. So the row total, and if you remember, compute the expected frequencies here. So this is what I'm doing. I'm computing the expected frequencies and and comparing them to the observed frequencies. So here we go. It's the row total times the column total divided by the total number of observations. Okay, and here's what my figures are. Step 4, apply the formula and compute the chi-square statistic. Here's this fancy looking chi-square formula, and don't let it scare you. It's chi-square equals the sum times, in parentheses, the observed frequencies minus the expected frequencies squared to get rid of the sign, divided by the expected frequencies. Okay, so here we go. Let's figure it out. 5 minus 17.5 equals minus 12.5, or negative 12.5. Here it's 35 minus 22.5 equals 12.5, and 12.5 and negative 12.5. Okay, so that's the difference between the observed and the expected. Got it? The next step, 4b, is compute the squared differences. So we square them up. 12.5 times negative 12.5 equals 156.25, and doing that for each cell. And step 4c, squared differences divided by the expected value. So we simply take 156.25, which is the squared differences, divided by 17.5 in this cell, which is the expected, 22.5 in this cell, which is the expected here, 17.5 in this cell, which is the expected here, and 22.5 divided by 22.5, which was the expected in this cell. Okay, sum up across the cells. Okay, here you go. The chi-square equals 31.7. Step 5, determine how many degrees of freedom there are. Okay, so the degrees of freedom equal the number of rows minus 1 times the number of columns minus 1. So the degrees of freedom, so we have how many rows? 2. How many columns? 2. Minus 1 equals 1 times 1 equals 1 degree of freedom. Okay? Step 6, check the chi-square distribution table in the back of the book, and we find that for chi-square equals 31.7 with a degree of freedom equal to 1, the table shows that the association between good looks and success is statistically significant at the 0.05 level. Got it? In other words, success differs according to whether individuals are good looking or not, or vice versa. And this difference is substantial enough not to be attributed to chance. Get it? That's a pretty neat example. Okay, step 7 is interpret your results in percent. So let's say that findings show that 88% N equals 35 of good-looking people are not successful, in contrast to only 25% N equals 10 of ugly people. Among those who are successful, only 14% are good-looking. 75% N equals 30 of ugly people are successful. So it's not what we thought. Okay, it maybe is hard work instead of good looks. And interpret your results. So think of what are the possible explanations for ugly people being more successful. Run that through your mind and think about it. Do they work harder? Do they get better grades in school? Do they go out on fewer dates and therefore have more time to study or work? A lot of interesting propositions there, huh? Okay, here is a word of caution. The chi-square statistic is sensitive to sample size. The larger the sample, the more likely it is that chi-square will yield significant results, even if the relationship between the variables is really weak. Okay, an example is the relationship between hair color and political orientation in a large sample. It really doesn't matter. Hair color and political orientation aren't connected, but they will look connected because samples might be large enough to skew the results. Okay, so let's recap. The chi-square test is used to assess whether there is a significant association between two nominal or ordinal variables. Null hypothesis equals no relationship between the variables. Chi-square does not provide info on strength of the association. We'll look at measures of strength not next week, but actually in the next video. Chi-square demonstrates whether there is a significant association between the variables, but not which is the cause of the other. Okay, reporting a chi-square test goes like this. There is a significant association between good looks and success. There is a statistically significant difference between the proportion of good-looking people who are successful versus the proportion of ugly people who are successful. And this is the way we write it. We open the parentheses, chi-square equals 31.7, semicolon, degrees of freedom equal 1, and when we look in the table in the back of the book, we find that P is less than 0.001. So at that level, it's statistically significant at the P equals 0.001 level, which means that we have a 99% chance of this being correct. Findings show that 88% N equals 35 of good-looking people are not successful, in contrast to only 25% N equals 10 of ugly people. And this is the way we would write this up. And it's the same for every time we report chi-square. A great book, by the way, is a book that I've been using for years. It's by the British Open Press, and it is called, let me just pull my copy out here, Survival Manual, SPSS Survival Manual. It's called SPSS Survival Manual, and it's by a woman named Julie Pallant, Julie Pallant. You could look that up on Amazon, and it's really good for all the statistical tests. Okay, and continuing on here, among those who are successful, only 14% and 5 are good-looking, and 75% N equals 30 of ugly people are successful. And you offer, in writing, possible explanations for these results, very, very like the ones that we discussed on the last slide. Okay, next we'll take a look at how we do chi-square in SPSS. And I hope this really helps you. I hope that you are getting the idea about chi-square and using it as a measure of association between nominal and ordinal variables. Okay, I will be posting the next set of videos and then a nice introduction into chi-square in SPSS. So take a look back when I get the other video lectures done, and we'll go ahead from here. If you have questions, please give me an email or post the question on the discussion board. Thank you, and I'll see you later.